Everything that you saw earlier was vibe coded thanks to the power of AI. That includes creating my own original sprites and animations that you see over here. So for example, you can see these sprite sheets that were appearing in my game earlier. These were all AI generated. And you've probably been seeing a lot of people posting about how you can use AI to generate art assets like that. However, if you've actually tried to use it yourself, you will know that there are several problems with getting it to work correctly within your game. If you actually look closely, the pixel art that AI generates is not real pixel art. Furthermore, if you look at the sprite sheets they generated, at first glance, this looks okay, but then you oftentimes end up with bleeding between the different frames. And this will result in things like this, where the images from one frame is bleeding into the other frame. Finally, one of the most annoying problems is that you'll have frame drifts. And so when you put it in a game, it just looks very jerky, janky, and it just doesn't look right. So in today's video, I'm going to walk through my entire step-by-step process in order to get AI-generated pixel art fully game ready. And as you can see, the pixel art is consistent, it's fully animated, and is fully integrated into a playable video game. So if you've ever wanted to know how to create game assets that not only look good on the surface, but also prepared in a way that you can integrate it into a game, this video is for you. Now, before we begin, as always, if you want to follow along with today's tutorial, I've made this entire cheat sheet along with all the reference images, prompt templates, additional files and resources as part of my Insiders Club. I regularly send out a newsletter that shares tips and tricks on vibe coding workflows, and within it, you also find resources from my other videos as well. But if you want to take things a step further, check out gamedev.com. This is my all-in-one resource for everything AI game development related. You'll find all of the agent skills that I've been working on that will help you automate and accelerate a lot of these workflows so that you don't have to do things manually. In addition to that, it also includes full-length tutorials, such as the one that you see here, that will take you through every single step and every single prompt in order to get from start to finish and end up with this fully integrated and polished game that you see over here. You also find other resources like full source code, prompts and plans from other projects that I've worked on. I build gamedev.com to help people all around the world fulfill their dreams of building games thanks to the power of AI. So head on over to the links in the description below. And without further ado, let's get started with today's tutorial on how to use AI to build game-ready assets. All right, so let's get started. So you can see here, the pirate character as well as the skeleton, both of these assets and the animations were all created using the exact workflow, which I'll be covering in today's tutorial. And just to quickly show you what I mean, this is the attack sprite sheet, this is the death sprite sheet, this is the hurt, and so on and so forth. Okay, you will see that I use the exact same process, similarly for the skeleton character as well. And like I said, these are all game ready, so they're equally spaced out. Then there are no height discrepancies, there's no weird flickering. And if I zoom in here, you will see that all of these are real pixels, none of the fake pixels that you get when you just use AI generation. At first glance, this looks pretty similar, but the moment you zoom in, you will see that the one on the left, all of these are fake pixels, right? There's all this blurring of lines. It brings a lot of problems when you want to start building pixel animations, as well as when you start to scale up the art to make it look great. So if you look at the one on the right, this is proper pixel art, so you can actually just scale it up to any resolution and it will still look sharp. So we'll be going through this entire process, including how to solve all the other issues related to AI-generated art. And I'll be giving you the prompts, the reference images, as well as a full walkthrough of how we get to the end, and finally into a game that you see over here that can be integrated. This technique that I'm going to show you today will apply regardless of which AI tool that you're using. So in most cases, you can either use the prompts from the prompt templates that I give you here, or in some cases, you can simply just give it a direct instruction such as remove the background, etc., etc. So this workflow works for any of your favorite AI tools. However, if you're using the Codex app, that image generation comes for free as part of your Codex subscription. So you don't need to separately have an API key, or you don't have to separately have an API key. You can simply go into Codex. So this means you don't actually need to have a separate API key setup or do anything to do anything special. You can just go into Codex and just do image generation. Okay, and this skill here will automatically generate all the images for you. For me, I use something called fel.ai because I basically use all the different models I use something called fel.ai because I run lots of experiments and I use different models like Nano 2 as well as GPT images 2 and several other things. And I like to have one API that gives me access to all of it. Okay, But in this case, you can make use of, but in this case, if you're just using images 2.0, you can just use Codex. Also, today's tutorial will focus really on GPT images 2.0. So all of the prompt templates and configurations are optimized for that. But you should be able to use Nano Banana 2 or any other image generation model as well. All right. So the whole point here is to just show you the techniques, and then you can use your favorite tool of choice. But this is try and tested with images 2.0. So if you want to follow along, this would be the best way. So just a quick overview of all the problems that we're seeking to solve today. All right. So the first one, like I mentioned, the most important one that helps you spot AI generated art straight away is you get mixels rather than pixels. And I've shown this many times now, but you can see these are fake pixels. Whereas if you go on to the right, these are real looking pixels. And this not just looks a lot better, but it allows you to scale it up to different resolutions because you can actually use pixel perfect scaling. All right. The other problem is that when you generate something with AI, as you see over here, it looks great at first, but you will immediately notice that if you try to split this up or try to integrate it directly into the game, you will have problems such as this, right? Where the image of one frame actually bleeds into the image of another frame. And this is really annoying. This is really annoying because you would anticipate that it would have generated a spreadsheet that would be game ready, but most of the time you would have to extract out the character and then place it in a rigid frame. And I'll show you how to do that. The third problem, and I think this is very apparent, and I'll show you a quick demonstration of this very shortly. All right, and the third problem is you get frame drifts. So when you generate the sprite sheet like this, and if you try to put it into the game, you will oftentimes end up with what you call frame drift. Okay, so you can see the character is just bouncing all over the frame because even though the animation looks right over here, when you start to lay them out, his feet are actually not anchored on the same spot. And when you put this into the game, it's just jumping all over the place and it's just very jarring. So what you want to do is actually fix it in such a way that his whole body does not jitter around the frame and is instead anchored at the same spot. Okay? There are many other problems that you encounter when you're using AI generated art, but if you can fix these three problems, you will be able to then have a game that plays and looks great. Okay, so the first thing that you want to do is that you want to be working from some kind of reference image that reflects the style that you want. As you can see from this game, I wanted to have this pixel art style, not too low fidelity, but not too high fidelity as well. And when I talk about fidelity, I'm just talking about how complex the character is. And in this case, I didn't want to look at like Mega Man or Mario. I wanted to have a little bit more definition, but I didn't want it to become overly complex as well. So here's the prompt template that I used to get this style. So you can see here, I actually said I wanted a low fidelity character art similar to a classic handheld or SNES RPG DMake. You can change this any way you want. And this technique obviously with pixel art works a lot better when it's not too complex. It can still work, but you will have a little bit more cleaning up to do. Okay, so the main things that you want to really focus on here is you want your AI to generate something that is 1024 by 1024. And this is very important. You can do this by specifying it within GPT image 2.0. There is a 1024 setting, and that's what you want to do. And ideally, you go for a square. Okay, so this is the first thing. The second thing that you want to do is that you want a flat chroma green background. You can use any other kinds of background, but I find that green backgrounds work very well for me. There's a bit more cleaning up to do, but it still generally works very well. A few more things to call out is that you want to have a strong readable silhouette and dark outline clusters, and you don't want it to be photorealistic. Okay, so this prompt is generally what I use when I want to get something in this style. You can change it any way you want. The main big thing is that you want it to be really big, and I'll explain why very shortly. Okay, so now that you have this reference image, it is not game ready. First of all, it's not animated. Secondly, it is suffering from the mixels problem. So if you just zoom straight in, you can straight away see that this has a lot of fake pixels because that's how image generation works. So the key step here is to do something called pixel snapping. I have to really give credit to the Sprite Fusion team for two reasons. First of all, they have something called the Sprite Fusion Pixel Snapper. This is completely open source. So you can download this for free and run the Pixel Snapper on any image that you want. It's extremely fast and it works really well. And the best part is that it's completely open source. So you can modify it and tune it any way that you want. If you prefer to just use an online tool, you can just go on to spritesheets.com, Pixel Snapper, and you can just drop your pixel art here. I will explain to you what this does very shortly, but this is just another easy way. So for me, what I did was I cloned this repository, and then I actually ported this as part of an agent skill. And I'll just show you this very quickly over here. You can see there's this Pixel Snapper skill. is a port of this skill with a bit more customization. So with this skill, I'm able to run this using AI, right? And this helps me to build the assets a lot quicker. I've made this pixel snapper available for the Vibe game community. This just makes things a lot easier, but like I said, it's entirely open source and free, so you can very simply just make use of this or download it and ask Codex or Cloudcode to create a port for you as well. All right, there's a little bit of magic that's going on here, but the main thing is that it takes in this input image and then it spits out something that is going to be pixel perfect. So let me just show it to you here. All right, you can see this is suffering with the off-grid or mixel effect. And then when you fix it with Pixel Snapper, it will turn this into an pixel snapped art for you. And if you really want to know, this is like the algorithm. All right, so basically it tries to, first of all, collapse the number of pixels to a fixed number. So this is K colors, and you can actually see this is what this number is over here. Okay, and then what happens after that, because you have decided the number of pixels you have and the number of colors you have, and then without going into too much detail, it tries to catch the edge along the two different axes, and then it looks at the pixels around the edge and then tries to pick just one pixel for that. And it works very well. This is a tool that is done by somebody that way smarter than I am, and I'm really glad that he's made this available for free, because now we are able to fix all of our pixel art. So what happens is that now you just have to run the pixel snapper on your reference image, okay? So what's going to happen here is that you're going to take this generated image that you have, and then you are just going to put this into this pixel snapper algorithm over here. And what you will get is the output over here is that you will get usually a smaller size, but still accurate version of your generated art. And this is great because with this that you have over here, you can scale it up back to 1024 by 1024 using the nearest neighbor algorithm. If you're not sure about what nearest neighbor is, it's a scaling setting that you do such that it preserves more of the pixel art nature of your art. It doesn't do something called anti-aliasing, or it doesn't blur the lines, which is not what you want. You use nearest neighbor and you always get crisp looking pixel art. Okay, so you can see here, right? This is the pixel snap version, and this was the AI generated version. At first glance, they look very similar, but you will know that this one will not have any strange mixels going on that you see over here. It will be ready to be integrated into your game. Okay. All right. So that's all right. And this now becomes your anchor. Okay. And if you've seen my other videos, this is the most important image that you have, because everything else for all of your other directions will now work based on this single input image, because this will be your reference for your entire character going forward. So just to help you visualize this a little bit better, this is the tool that I've been working on to make this process a little bit more intuitive. You can generate a source image, it will snap it down, and then it will scale it back up to this 1024 by 1024 image that you see over here. You will see that this is pixel perfect. There are no strange things going on. And if I show you the original one over here, if I zoom in, you can see this has a lot of strange pixels. This is a result of what comes up from the pixel snapper. And you can see this is much smaller as an image, but then you can just scale it up to 1024 by 1024 and it will still retain its sharpness. That's the reason why nearest neighbor scaling works very well, and you want to be using proper pixel art for your game. Okay, so now that you have this as your anchor, all right, this is now going to be used for all subsequent AI generation. And you want this to be big, okay? And the reason why you want this to be big is that you have seen here, right? The pixel snapping process can collapse things down to pretty small. So this is almost an order of magnitude smaller, and you can just scale it back up later. But if you use too small an image, it ends up being extra blurry. And oftentimes I've seen that if you use something like 512 by 512, 4256 by 256, the pixel snapping doesn't work as well, and it doesn't retain your character's like main characteristics. So now that you have your anchor, it is time to create your other facings. And this is a process that would be familiar to you if you've seen my other videos. Once you have your anchor, basically you can generate all other facings that you're using in your game. For me, in this game, you will see that to make things very simple, I only have one dimension, right? So it's just going from left to right. And actually right, if you look very carefully, is simply a flip version of the left one. So just jumping into it here, how do you do this step is the following. You use the following prompt template. The main thing here is that this input image, which is 1024 by 1024, needs to be accompanied by a second reference image, which is simply a 1024 by 1024 checkered pixel matrix. This is a tip that helps to constrain subsequent images to resemble pixel art as well. All right. So here's a better overview of what this is. So you just pass in this image. You can ask your favorite AI to generate this for you, or I've also made this reference image available as part of the free resources accompanying this video. But if you zoom in on this, you will realize that every single pixel just alternates between white and black. Okay. And this second reference image really helps to keep the pixel art style when it generates it. And you can see this is the prompt template that I use to generate this side-facing character. You can just change this any way you want, but the main things are very similar, is that you want this to be output as 1024 by 1024, and you want to have the chroma background to be retained as well. But here are the actual settings. You must be using edit mode because you're passing in some reference images and you're editing it, and you want this to be as high quality as possible, and you want this to be 1024 by 1024, like I said. Okay. So this will give you the result, which is here. And this already looks really good. But remember that this is still an AI generated image. So it's still going to suffer from the blurry pixels. So the next step is to do the same thing again that we did from step 1 to step 2. We're going to snap this image. And you just have to use the same tool that you have over here to snap it. So when you snap it, it will get shrunk down after it gets snapped, but this will be pixel perfect. And then you just scale it up one more time to 1024 by 1024. So this will become yet another anchor for subsequent generations for all the animations that are facing in this direction. So this is just really the key process here, is that whenever you generate an image, pixel snap it and then scale it up and then use that as your source image for your subsequent steps. And this will help you to preserve the consistency as well as the art style and allow you to continue to pixel snap it again and again. Okay, so now you have this anchor. It is time to now go ahead and animate this. You can have all the animations such as being hurt, attack, and then as you can see for the skeleton, you can have a death animation as well. So with this west-facing anchor that you have, we can now use this to generate sprite sheets. From this stage onwards, you're going to repeat the process, okay? The main idea here is that when you generate your sprite sheet, you will need to pixel snap this as well. Because remember, this is still going to be AI-generated mixels, and you want to pixel snap every single one of these frames so that you get crisp looking animations. Now, if you see my other video, this is going to be very familiar to you, but I'm going to focus especially on how to make sure that these frames that you get out can be pixel snapped properly. Because if you try to simply yank these images out, or you try to pixel snap the whole image, it's just not going to work. And there are a lot of reasons why that will happen. So this is the process that I'm going to outline to you that will allow you to have your sprite sheets to be crisp, to be properly pixel art, as well as game ready. So you won't have all these weird issues that come up with the alignment as well as bleeding of the anchors. So for all of your sprite sheets, what you want to do is that you're going to pass in the pixel snap anchor that you have from the previous step. And then now you want to pass in a canvas that is similarly going to have alternating pixels, okay? And an aspect ratio that will allow you to effectively lay out the animations in this way. So the reason why you want to pass in this reference pose board, which is 2048 by 1536, is that this gives you a 4:3 aspect ratio. It will allow you to have, up to 12 frames of animation, even though I generally try to just do things between 8 to 10. And if you actually zoom in into each one of them, it's the same checkered pattern as well. And this really helps to guide the image generation to give you the art that you want. The other reason why it needs to be as big as this is that each of these cells are 512 by 512, and that's pretty big. And the reason why you want this is that, remember when I told you the pixel snapping algorithm tends to make things very small? You want to make sure that when you get these results, that when you start to extract these frames out for pixel snapping, that it's large enough. So 512 by 512 roughly is the minimum size that you want. I tried sizes that were a lot smaller, and they generally give really bad results. So this is where you want to be. You can even go even bigger, but then this will cost you more. So this is the sweet spot in terms of that. Okay. All right. So here's the prompt template. So like I said, the first thing you want to pass in is the anchor, identity anchor. The second one is the canvas or the pose board. And the same things again, you want to have the chroma background, and you can adjust this in any way that you want for your animation. Now, when you're passing an animation, I find that there's two ways you can do it. So first one is that you can provide a frame by frame description. So you can literally say frame 1 is settle, frame 2, frame 3, frame 4. And this kind of works, but I've also seen times where this ends up with inconsistent frames and animations. Another way you can do it is just simply provide motion guidance, right? Just say create 8 readable attack poses that feel like a coherent short game animation. And this also works very well. So you can play around with it. Sometimes providing the exact frame references works very well, like for death animations. And sometimes just providing a loose definition also works just as well. The main thing to recognize is that this is what I found to be quite useful, is that for idle, you want to have about 10 frames, attack 8, hurt 6, jump 6, and then def 10. This is just my kind of guide and like where you want to be specific versus loose. But it's trial and error, and I would say that if one doesn't work for you, just switch to the other. So once you've done this, you will actually end up with a sprite sheet that's generated for you. And like I said, at first glance, this is actually pretty good, but you will actually see a bunch of issues, but you will also miss a bunch of issues. So ignore the fact that it actually switches hands. You don't really notice it when you're playing the game, but he does switch his hands in his attack over here. The main thing that you will see here is that this is actually not evenly laid out. So if you just quickly go and crop and split this into equal segments, you will end up with situations like this. And I call this the frame recovery step. So you can see if you just crop it with equal to 512 by 512 boxes across the entire generated sprite sheet, you have this problem. So what you can do is just tell your AI to do, like, basically try to key out the chroma, and then from there, crop to the bounding box of the character, and then make sure you get the character out so that you can later on place this in a proper grid for you. There's no external AI call or image generation call for this. You just ask your AI to do it, and usually you use like Pillow or something to abstract this out for you. You will see that there's still some little things like all these little green fragments. It doesn't really matter for this step because we are going to pixel snap it later and then clean it up. Okay, the main thing is that you want to extract these things out so that you can avoid this problem that you see over here. So now the next problem that you're going to have is that this happens a lot if you're doing walk cycles using video generation, but it can happen as well for something like this. So for example, if you actually look at this image over here, you might find that you don't need all of these frames. So what you want to do is just pick frames that you want to use as part of your animation. In fact, I would suggest that for any attack animation, do not include the idle frame as well. It makes things a little bit more sluggish. But for my game, I actually didn't bother. I just dumped it in. But if you actually look at how sprite sheets are, you usually don't do the idle animation first. So let me just show you the tool that I built. So this is really prevalent for walk animation. So you can see this is all the frames that were generated by AI. And you don't really need all of them. Okay, so you can see this tool here. What I'm going to do is that I'm just going to say, okay, I want this as my start frame. And then I just want to do one full cycle. Something like this. Okay, and then we'll set as the add. And I'm going to say I want a total of 8 or 10 frames. So I'm going to distribute it, and then I'm going to play it back for you. And you can see, right? So this is really like a curation process. And this is particularly prevalent for walk cycles, but you might want to be doing it for your generated sprite sheets as well. You don't need all the frames all the time. So once you've created the frames that you have over here, and what's the next step? You want to pixel snap again. So what you have to do is that now you've selected the frames that you wanted, just run it through the pixel snapping algorithm again using the tool. And this time it'll give you all of your frames, but they'll all be fixed correctly. You just use the same process again, and then you get them to any resolution that you want. You can get it to 1024 by 1024 or 256 by 256 or 512 by 512. So I went with 256 by 256 for the frame size for my game. And that's a good and decent size for it to look good in the game without taking up too much memory as well. Okay. Now, the other big problem that you want to solve is the anchoring. This one, I'll show it to you again with this animation that you see over here. Okay, so you can see if you don't anchor the character properly, you're going to be in a position where it's just going to be sliding all around the place. So what you want to do here is that you want to start to align your character such that across all the frames, he's still in the same position. And there's several ways of doing this. You can actually ask the AI to do it for you. Or you can actually ask it to build a tool for you. That's exactly what I did. So let me just show you this frame aligner here. So I can just scrub through all of the different frames. Okay, and you can see that this one has already been fixed. And I added some onion skinning or frame layering so you can actually see it across and allows me to just shift things around. So the way that I did it was I just basically tried to align things across the frames such that the eyes were at the same level. But you will see that prior to you doing this anchoring, you will see that even after your recovery, you will have your frames shifted like that. So this tool allows you to just very quickly move things such that everything looks right, and then you can export it over here. Okay, you can ask AI to do it for you. It works pretty well sometimes, but I find that when you're dealing with 8 frames, sometimes it's just a lot easier for you to just jump into it and make the manual edits yourself. And this will help to prevent that sliding that you see over there. So finally, once you've done that, there's a few more things that you want to do, but these things don't really require too much to think about. So I'm just going to tell you here, right? So the next thing you want to do is just remove the background once you've got your, so now you've got your pixel frames, you've got them anchored correctly within each frame. And then all you have to do at this point is to just remove the background And you can do several things. Because it's pixel snap, you might be able to just use a simple Python script to clean it up. You will probably want to do something called a despeckle pass, or you can use an AI background removal, which will work very well as well. And then the other thing is that you will sometimes see that there's potentially just small height differences between your characters, between your frames. You can ask your AI to normalize it as well. But usually if you follow this process, you will find that the characters are really pretty much the correct sizes because you've gone through the whole process of cleaning things up and putting things together using Pixel Perfect. Using the pixel snapping. Okay, so finally, you just want to pack them into a final sprite sheet that you see over here. Because I'm using 256 by 256, it's going to be 1280 by 512. And like you can see over here, all right, so all these are going to be the same. And you can see it's sufficiently large enough that you can get all the detail that you want, yet not being too big such that it makes your game bloated. And so these sprite sheets that you can see here are all already game ready to be put into your game. Because this process is actually quite standard, I've been working on skills to automate this. And in fact, that's exactly what I did to do the skeleton. So you can see the skeleton has exactly the same set of animations. They're all generated with AI as well, so there's some variation, but they're all pixel perfect. And the reason why I was able to do this is that I've been working on several tools as well as agent skills that allow you to effectively get to this stage without having to do all of these steps that you see here manually, except for parts where you want to do some small tweaks. Everything else over here can be done for you. So the generation, the pixel snapping, the laying out, the normalization, and everything else. And a lot of these are in the form of skills, so you can drop it in. It works with your favorite agent tools, whether it's Cursor, Cloud Code, Codex, or whatever. It allows you to accelerate and just get to the end result without having to do all of these steps manually by yourself. That's also in gamedev.com, so if that interests you, check it out in the links in the description below. So if you're interested in knowing how you can integrate this and build an entire game from it, this is exactly what I'm working on for a subsequent video where I'm going to show you how you basically can take all of these assets and then put them together into a game such that you can play with them. This is going to be released in some early fashion for gamedev members, but then I'll also be doing a public version of this. And as you can see, I'll be showing you the exact prompts that you use to integrate, to put the character in, add the enemy in as well, and then all of the steps that it will take such that you can do things like attack, add a health system that you see over here, with every single prompt step by step such that you can go ahead and integrate it and end up with this exact game that you see over here with the assets integrated. All right, so that brings us to the end of today's tutorial. I hope that you found it useful. I think that being able to do pixel art in this way is a huge unlock so that you can actually get games that look good as well. So if you enjoyed today's video, give it a like, hit that subscribe button, and don't forget to turn on notifications so that you will always be the first to know when new content like this drops. So one thing that you notice is that I didn't really talk too much about how I got this walk cycle working in this game. And the reason is that when you use image generation models to create walk cycles, you generally will not be able to get a good result. So if you want to know how to fix it using a technique using video generation, and that will also work with this pixel snapping approach, definitely check out this video that you see over here. All right, till next time, I'll be seeing you.